Hi, we'll continue our discussion on trusses. Now, I will show you how you can do truss element design, section design, using the software. Okay, all you need to do is to click on still truss section design. Now, before you continue, I would like you to understand some things. The length of the element is very important, because the length obviously is going to control the it's going to have an effect on the compressive strength PC, okay, which is a function of the slenderness. It's very, very important. Longer elements, if the member is in compression, might need a little bit of design here and there. Okay, let's do it. Now, the first thing you do, of course, you go through the elements and decide which elements you want to design. Of course, some of them are similar. You can just design one and then match the property. Okay, a very good example. This element is minus 6.75. That is in compression, and the length is 3 meters. Okay, I can look for another element that is close to it. It's almost at a league of its own, so I'll just leave it apart. But let's take this element 1, which is minus 9.37, and the length is also 5,000. Let me also say this. You can match properties of similar elements. We'll see that later. Especially, always make sure that the lengths are the same or almost the same. Okay, and also that the both elements want to match their properties, that they're either the same in compression or same in tension. Okay, so we move on. First of all, I will select element 1. Then I will now come to this section. I will select a particular section. If I want to use angle iron, or universal beam, universal column, circular hollow section, square hollow section, of course equal angle on equal angle a channel. Now in this case I want to use an equal angle. Okay, now the next I will have to select the section type I want, the designation. Let's try, for instance, 50 by 50 by 5, the thickness. And if you read very carefully, you see the note that we have also put forward. Note, if a member is in compression, you must enter compressive strength PC to finish the design. CBS 5950 part 1 or Steel Designer's Manual, Reynolds, table 23 and 24. Okay, so you must enter the compressive strength PC for you to finish the design. And of course you can get this from either BS 5950 part 1 or from the Steel Designer's Manual, table 23 or 24. Now table 23 actually explains, depending on the type of element section you are dealing with, whether the curve is going to be C or A or B or D. Okay, for an equal angle iron, if you check table 23, it's actually a C curve. So you now go to table 24, and then I'm talking about when you are looking at Steel Designer's Manual. Okay, and then at table 24 you can now be able to choose based on, let's scroll down. Of course, all these are the section properties. If you scroll all the way down, under steel section design, compression member only. Now you can now be able to enter the based on the compression member's slenderness. You'll be able to enter the, once you take this value, go to the table, and then you'll be able to check this. Now from the value we are getting, you discover that the value is too high. The higher the value, the more likely the member is to fail. There's no doubt about it, because the higher your slenderness ratio, the compression member slenderness, of course, the higher it is, the smaller the compressive strength is going to be. and the more likely your member is to fail in compression. And all this is also a function of the load as well as a function of the length. And the honest truth is that the length of the element to a large extent controls the compressive strength. Okay, you can see this section is not workable because the last figure we have in the table, for the compressive strength of compressive slenderness is 350. So this is a no. I have to go again and select another member. Take this. Basically, steel design is more of going front and back, until you get a stable member. Okay. You can see this is not also okay for us. You can see this is 427. You can also combine the number of elements of sections. In this case, assuming for instance we want to have number of sections to be 2. I want to have 2 angle iron, side by side to each other. I'll make these 2. You can see that of course this comes down to 213. Okay, and then you can go back and check 213 in the table. I can get under x 275. I can get that is the I can get like say 36 to be my compressive strength. So you can see I am okay. The section is okay because the compressive resistance PC certainly is obviously higher than the maximum compressive force. But that is assuming that we're using 2 sections side by side. If you don't want to use 2 sections side by side, we can go ahead. If you change any of this value, please always remember to come back because the value of you can see the value of our compression member slenderness have changed. You have to provide a new value for your compressive strength PC. Now let's assume we're using a higher value. Let's say 90 by 6. You can see this has come down. This is 280, but it's still not too good enough. Okay, but let's check. At 280, we have 22. Okay, I'll enter 22. Okay, it's okay. Then it passed. So at 90 by 90 is still okay. Okay, let's try something else. Let's assume 80 by 80. You can see this is 318. 318 should be giving us that should be 18, roughly 18. So I'll use 18. You can see we're still okay at 80. So this actually the way to do your steel design. It's more of trying a section to know which section works. Thanks for the software. I mean, once you enter the compressive strength PC, automatically it re-validates your check to make sure to check if the section is adequate or not. Okay, so you can just be going front and back like that until you get a section that you feel satisfied with. Another way we can also try this again, 70 by 70. You can see we have 367, so which is no, I mean it's totally off. Okay, I'll just go back to 80. Excuse me, 80 by 6. This is 318, and we used that is 18. So you can see this is actually the way to do your steel design. Most of the things you need to do has been done by the software. All you need to do, as I said earlier, first of all, select the element you want to do the steel design for. You can see here I have all the elements I have in my work. I have up from element 1 to element 13. Cool. Then the next thing is for you to apportion a section to it. Just go to under steel section type, select the element type you want to use, the section type you want to use. In this case, we are using an equal angle. Once you have selected your equal angle, the next you now select the size of the element, the section designation, the section sizes from the drop down. Automatically, I mean, is there. Once you select, automatically the software we pull down all that you need. All the section properties are all there. Okay, the only thing the software requires from you is to enter the compressive strength PC. Once you enter your compressive strength PC, the software will do the rest for you. Okay, and of course, to get your compressive strength PC, you need the compression member slenderness, which is already calculated. All you need to do is to take this value, go to table, take this value, go to table 23 and 24 in Designer's Manual, or BS 5950 part 1. Once you get there, pick up your, based on this value, pick up your compressive strength PC. In this case, we have 18, and press OK, and the software will do the rest for you. It will calculate your compression resistance, and then it will also do your check to know if the member is okay. And once the member is okay, good and fine, the section is okay. You can always be going through and through, to make sure you get an appropriate section for you. And remember, the section type, you can use any of these. The universal, depending on the kind of steel, the roof truss you are designing, the choice is all yours to make. Okay, now if the member is in tension, let's look for a member that is in tension. You can see this one, we have 5.62. okay, I can still select an equal iron angle, and then I can select the size I want. Okay, let's start with a lower one. Now it's automatic. Once the member is in tension, the software does all the calculation for you automatic. Okay, it will check for section, the tensions, check for to know whether it's okay or not, and if it is okay, you can say section is okay. In this case, the element is not in compression, so you have no business here. Okay, that is all you need to do. If it is in tension, it will do all the checks for you, to do the calculation, do all the checks for you. If the check is not okay, you will see here written check not okay. If the check is okay, that means that particular section you selected is okay. I mean, you just move forward. You can see it already calculated the tensile resistance PT. It's already calculated, so you actually don't do anything. Let me repeat what I've just said. If the member is in tension, the software does all the calculations for you. You don't enter any value. Okay, all you need to do is to check and make sure that the tensile check status is okay. Once it is okay, section is okay, then the section is okay. If the section is not okay, of course you go back and choose another section. The only place you have work to do is if the section is in compression. In that case, you might have to take this value and go to the table and pick the table we talked about earlier, and pick your compressive strength PC. And once you have done that, it will calculate your compression resistance PC, and then check if the section is okay or not. Once it is okay, it will tell you, it's okay, you can move forward. If it is not okay, then you will have to make a change. And please remember, you can see this is our element section. You don't need to bother about what is here. You only bother about what is here when you only mind what is here only if you are selecting the section at first. Apart from that, you don't have any business with it anymore. Okay, that is how to do your element design. Okay, and again, if a section is similar to each other, a very good example, assuming for instance we want to use the same section we're using 1 for 6. Okay, although 6 should have given us a much more smaller member. Okay, but let's assume we want to use the same element. All I need to do is to check 6 and then click on 1, right? Check 6, click on 1, and click match properties. This operation will make still section properties for selected element the same with checked elements. Remember, checked elements. Are you sure you want to do this? Yes, of course. So as does it. If you click here, you can see it has the same member designation. Okay, that is it about your steel design. Okay, it's all about going to and fro until you've got an appropriate section, and if it is okay, it will tell you. If it's not okay, it will tell you. Okay, Just take your time, be patient, and make sure you do the right thing. Remember, finally, it is important, you must always enter, if you are designing like we did in element 1, you must always, and please, after matching properties, always on check in case you want to do another one. You must always enter the compressive strength PC to finish the design. That is the only thing the software requires from you if a member is in compression. Okay, once you enter it, and to enter it, you go to this table, either from BS 5950 part 1 or State Designer's Manual table 23 and table 24. Table 23 will just tell you the curve you need, like in this angle iron is curve C, and then table 24 obviously will tell you about the of course, you now from table 24 you will pick your compressive strength PC based on your compressive member slenderness. That's all you need to do. Hope you have enjoyed this. Thank you.